Number 28, simplify the rational expression. State any restrictions on the variable. Z to the fourth minus 12z squared plus 35 all over z to the fourth minus 9z squared plus 14. Okay, so first thing I notice is this big exponent, z to the fourth. But it is a trinomial. So I can factor this thing. I'm just going to have to make a little adjustment. I'm going to make a substitution. But this is these two trinomials are examples of what we call quadratic in form. That means that they just with a simple substitution we can turn them into a quadratic, because this exponent is double this exponent. If we let u equal 12, if we let u equal z squared, this right here, we're just going to call it u. Then u squared would be what we have up here, z to the fourth. Okay, so we're going to make this substitution, and then when we're going to solve it for u, and then we'll have to do another substitution to solve for z. So we can write this as u squared minus 12u plus 35 over u squared minus 9u plus 14. Okay. Now these are pretty easy to factor. I can do 5 times 7, and 5 plus 7 gives me, so let's factor that as u minus 5 times u minus 7 over, and then this one, let's do 2 times 7, make them both negative, so you'll have u minus 2 times u minus 7. There. Okay, so that's the factored version with u. The u minus 7's cancel. So I've got u minus 5 over u minus 2, but I'm solving for x. So I need to, I'm actually solving for z in this problem. So I need to substitute back in. I know that u is z squared. So I need to write that as z squared minus 5 over z squared minus 2 here. Okay, so this is my answer because I can't get either one of these to factor anymore. That's as far as I can take it because they're not difference of squares. But they did also say in the problem to state any restrictions on the variable. Okay, so we got to think about, remember when you're working with these types of problems, you cannot get 0 in the denominator. So you have to make sure that your denominator never equals 0. Okay, so that means that the z squared minus 2 cannot equal 0. So let's solve this for z. Add 2 to both sides. Z squared equals 2. Then do square root property. Z equals plus or minus the square root of 2. So that's a restriction on z right there. Also, because we had u minus 7 in the denominator at one point, we've got to solve that as well. We've got to make sure that's never equal to 0. So u minus 7 cannot equal 0. And remember, u is the same as z squared minus 7 cannot equal 0. Add 7, so z squared cannot equal 7. Z cannot equal plus or minus the square root of 7. So these are the restrictions. So this is the answer, z squared minus 5 over z squared minus 2. But z cannot equal plus or minus square root 2. Z cannot equal plus or minus square root 7. So let's look at our answer choices, see if we can find that. So I had z squared minus 5 over z squared minus 2. So I see that A, C, and D. B is the only one I can eliminate so far. And my restrictions, z cannot equal plus or minus square root 7 plus or minus square root 2. So I see that in A. It's got to be A.